In this video, we are defining what is an event, formally of course. So first of all, we have our data, which is normal. It's very standard actually. So we have our order ID, item ID, we have our activities, timestamps, resources, nothing out of the ordinary of course. Here, if we pick our case to be the order, we get 6 variants. So it means that for this sequence of events, we have 6 possibilities from our data. If we pick the case to be a item, we get 2 variants. So it's the same idea as previously. Now the issues start here when we combine them. And here we get 1033 variants. And this is what we call a spaghetti. So this is the formal definition. We will get into more details later on. C is for case, A for activity, T for timestamps. So these 3 are mandatory. R for resource, and D for data. These are attributes, and so these 2 are attributes, and they can change. So let's start for a moment with what we know. What is an event? An event is simply a row. So here, this is an event. We have been, if we watched the previous videos, we have been using these algorithms and these definitions, and we have been feeding these events to these algorithms. So let's do a little bit of a math recap. The reason why we're using tuples and not sets is because order matters for us. So here you can see for sets, AB is the same thing as BA, which is not the case for us in tuples. Because first we have the case, then activity, then timestamps. Also, a good reminder to keep in mind is that we are ranking our events from to, and this would map to O1. The same thing that you see here. And here also, for example, you can change this with activity, for example. Activity, and here you'd have pick item. So that would give back the name of your event. Now, let's talk a bit about data. So we have an issue. You have a system in Germany. It would be an activity would be called Vorgang. In France, it would be called activité. I don't know, or you would call it task instead of activity. And that creates a problem. You need a way to communicate between one system or one tool and another. So there was a standard that was created. It's a bit like a data convention. It's called XES. XES stands for Extensible Event Stream. And the idea is that it's an XML. So it's basically an XML file with extra rules. So this is like the tree structure that you can see in an XML file. You would have the log inside of it. You'd have a trace. Trace is multiple events, as you can see here, and every event is like a row and it has multiple attributes. And here we have 2 data types. So these are the primitives that we accept. These are the primitives, and these are collection data type. These are the collection data type. So I'll just write it here. Collection, and these are on top are the primitive. And if you know Python, list acts a bit like I would say an array. So you'd have an index, you'd have 0, for example, and every index would map to a certain value. And those values need to be one of these primitive types. And container would act, if you know Python, it would act more or less like a dictionary. And there is still the constraint that every value in the container needs to be one of these type values. So sorry, there was something to correct here. List and container can take themselves lists and containers. So either a collection or primitives. And this is the names of the columns. If you're transferring data from one side to another, imagine in your head you have system A and system B. So system A, sys A, and here I would put it sys B. And between the transfer, you're gonna use XES. And these are the names. So concept name is for activities, here for data, for timestamp data. resources, who's doing that event. And here you'd have for a life cycle, let's say you're starting an action and you're completing an action. So you'd have two events that represent a certain life cycle step in that event. From the beginning of this video, I've been showing you the structure of our event, and it was pretty rigid. So we have been talking CAT and R&D, which are not mandatory, basically 5 fixed slots. But in reality, what's happening is that from one company to another, we have a big differentiation. They are not truly following these rules that we set already. So it's like an open bag of named fields, and then you can add whatever you want. So from our position, the main issue comes to how do we choose the C? That's what's going to make or break our analysis, of course. So it's not a fixed slot or something that you will have that's decided for you when you're seeing a new log. It's where things break if you make the wrong choice, of course. Now, back to our theoretical understanding. So here we have definition of a variant. What is a variant? So let's say you have 500 orders. They all go through the same motion. If they all go through the same motion, which is here, place, pick, pack, and ship, they represent only one variant. Of course, if there is a change, for example, here, I don't know, ship again, but this model breaks in one case. If you have a one-to-many relationship, for example, one order has many items. Let's say you are ordering 10 items from Amazon. So which do we pick? Should we pick the item as a case, or should we pick order? So the answer is, it depends. So if we pick case as being the order, we'd have 6 variants. It would be clean. Same would happen with if case is item. It would still be clean. If we look at order A and order B, we would have here, what's happening is that it's basically the same process, but the events of pick and pack here and here are happening at different timings. And this creates 2 different variants. So every difference on what's happening, on when and what type of process is happening at which time, will create a different variant. And this cramming of this one-to-many relationship into a situation where we can't really cram it will create an explosion of variance. And that's a problem for our model. So how do we fix this? The fix is actually pretty simple. So we do not force to have one case. So this was classical process mining. The new way to do it is that every event, this is the new way, I'll do it in green. This is the new way. Every event has multiple relationships with multiple objects. So we're not really improving the case notion. We're just adding new rules. We're adding relationships between items. Watch the video to understand how OCEL 2.0 works better. So to summarize all of this, what is OCEL? OCEL is not a database rule. So it's not self-describing, you still need the standards. It's not really reality, you're sort of making an abstraction of the world. And until now, all of the videos in this channel have been based on it. So if you like the content, please like and subscribe, and leave a comment and follow me on LinkedIn.